We've looked at limits where we can just plug in the value that we're approaching, and we've looked at limits where we couldn't immediately plug things in, but we could algebraically manipulate things and plug things in. And now we want to look at what happens if we can't get rid of that division by zero. What happens if there's still something going wrong when we try to plug in our value? So let's look at this problem. It asks for the limit of 1 over x minus 1 squared as x approaches 1. Now, you can clearly see that if we plug in 1 to the denominator, 1 minus 1 is 0, 0 squared is 0, and we're dividing by 0. Notice in this case that we would have 1 divided by 0. We're no longer dealing with a 0 over 0, which is what we've been dealing with the other limits. We now have 1 divided by 0. And you can see, obviously, the numerator, nothing is going to factor there. We don't have any square roots that we can try to do rationalization with. Nothing can be done to get rid of this division by 0. So what happens when we can't get rid of the division by 0 is what's really happening is when we get really close to 0, we're dividing by a really, really small number, which means that we're either going to approach positive infinity or negative infinity. So we just have to kind of think about what's going to happen, and really we need to divide this up into two separate limits. We want to think about what happens as I come in from the left-hand side, so the limit as x approaches 1 from the left-hand side of that same function, and what happens as I come in from the right-hand side. So the limit of 1 over x minus 1 squared as x approaches 1 from the right-hand side. And in this case, if we think about a number to the left of 1, when we plug that in, we're going to get, let's say we just go with 1/2 for now. 1/2 minus 1 is negative 1/2, but when we square that, that becomes positive 1/4, and we would get 4. So since x minus 1 squared will always be positive no matter what, we could say that the limit from the left is going to be positive infinity, because 1 divided by a really small positive number is going to be positive infinity. And same thing for the right side. So as we come in from the right side, we're going to get a positive number when we subtract. It's going to stay positive when we square. And since we're dividing a positive number by a really small positive number, we're going to approach infinity. And since we approach infinity from both sides, we can go back to our original limit and say that that limit will be positive infinity. Now, technically, this means that the limit does not exist, but it's a specific way in which the limit does not exist. Let's look at another example. Now, in this case, we're looking still as we're still approaching 1. We're still getting a number that is not 0, in this case negative 1, divided by a number that is 0, which is going to suggest that we have a vertical asymptote. And so, just like before, let's divide this into two separate limits. Let's see what happens from the left-hand side, and let's think about what happens as we come in, from the right-hand side. And if we think about that, we have, when we take a number that is smaller than 1, so imagine that let's imagine we plug in 1/2 here for x. Notice we'll get 1/2 minus 1, which is negative 1/2. But then when we take negative 1 divided by negative 1/2, notice that we're getting negative divided by negative. So when we're coming in from the left side, we're getting negative divided by negative, which means, of course, positive. So we're going to approach positive infinity. Now, if we come in from the right-hand side, if we pick a number bigger than 1, like 1 1.5 or 3/2. 3/2 minus 1 is positive 1/2, but then when we take the negative 1 and divide by a positive number, we get a negative number, and we'll see that as we approach 1 from the right-hand side, we're going to approach negative infinity. And so what we would say here, all we can say here for this overall limit is that it does not exist, because from one side we're going to positive infinity and from the other side we're going to negative infinity. Okay, let's look at one more example. Now this one's not quite as obvious that we're dealing with something where we would have division by 0, but let's think about what we know about cotangent. And we know that we can rewrite cotangent as cosine divided by sine. And we know, of course, that the sine of pi is 0 and the cosine of pi is negative 1. So just like before, we've got a negative number, negative 1 divided by 0. We're looking at a vertical asymptote occurring at pi. We just need to see what happens on both sides. So let's see what the limit, let's think about what the limit as x approaches pi from the left-hand side and of cotangent. And let's see about the limit as x approaches pi from the right-hand side of cotangent. And so let's just think about this. If we're less than pi, we're going to be in the second quadrant. In the second quadrant, cosine is going to be negative, and sine will be positive. Negative divided by positive is negative, and so we're going to be approaching negative infinity. Likewise, if we think about a number where the number is greater than pi but close to pi, that means we're going to be in the third quadrant. In the third quadrant, cosine and sine are both going to be positive, so when we divide, they'll both be negative, but when we divide, we'll get negative divided by negative, which is going to give us positive infinity. So we can see that the limit from the left is negative infinity, the limit from the right is positive infinity, but this overall limit does not exist.